If you want to run strong AI closer to your own machine, this is the video. Not the hype version, the useful version. Because right now a lot of people are making the same mistake. They see a benchmark chart, they see a giant parameter number, and they assume the biggest open model is automatically the best local model. That is how you end up with a setup that is expensive, noisy, insecure, and somehow still disappointing. So today we are doing this properly. We are talking about the best local AI options right now, where each one actually fits, what stack makes sense for beginners versus serious builders, what a secure setup needs before you let an agent touch your files or terminal, and how to think about budget without lighting money on fire. We are covering Gemma 4, DeepSeek V4, Qwen 3.6, Mistral Small 4, Ollama, llama.cpp, vLLM, Open Web UI, and sandboxed agent workflows. And by the end, you should know whether you need a tiny offline model, a strong single-box coding setup, or a real Homelab inference rig. If you want more, the first thing to understand is that local AI is finally interesting for reasons that go beyond privacy talking points. Google DeepMind's Gemma 4 page is one of the clearest signals of that shift. The small E2B and E4B variants are pitched for mobile and IoT devices, with offline, near-zero latency edge use. The bigger 26B and 31B models are pitched for personal computers, coding assistants, and agentic workflows, and Google explicitly says they are optimized for consumer GPS. That is a huge statement. It means the companies building frontier-adjacent open models are no longer treating local deployment like a hobbyist afterthought. DeepSeek is making a different but related argument. Its V4 release is about long context, efficiency, agent use, and compatibility with both OpenAI-style and Anthropic-style APIs. Qwen is making the coding case even more directly with Qwen 3.6, where the official model card leans hard into agentic coding and repository-level reasoning. Mistral Small 4 is pitching an open hybrid model that can handle reasoning, coding, tools, document work, and structured outputs. Put that together, and the real story is this. Local AI is no longer just about running something offline because you can. It is about choosing the right layer of control. Lower latency, lower recurring cost for repeated tasks, better data locality, more predictable behavior, and in some cases, better security because if you are starting from scratch and you want a model family that actually respects real-world hardware, Gemma 4 is one of the best places to begin. The official Gemma 4 page makes the split very easy to understand. E2B and E4B are the efficiency-first part of the family. Google positions them for edge devices, real-time processing, and fully offline use. That is important because it gives you a very clear mental model for what these are good at. Assistant tasks, lightweight automation, document help, vision-adjacent workflows, and offline personal use where you care more about responsiveness and control than about absolute frontier reasoning. This is the lane where a lot of people should stay longer than they think. If your real job is summarizing notes, cleaning up emails, extracting structure from documents, helping with small scripts, or giving yourself a private on-device helper, you do not need to jump straight to the biggest model you can find. A smaller model that is always available, fast, and cheap to run is often more valuable than a giant model that feels like a science project every time you touch it. So if you're Now, if you do have a stronger workstation and you want a real local first model for coding, research, and agentic workflows, the bigger Gemma 4 models deserve serious attention. Google DeepMind is very explicit here. The 26B and 31B models are aimed at IDEs, coding assistants, and agentic workflows, and are optimized for consumer GPS. That is exactly the kind of wording you want to see in 2026, because it implies the model family was designed with practical workstation deployment in mind, not just leaderboard theater. This is why Gemma 4 may be the best all-around local recommendation for a lot of serious builders right now. It has a clean official positioning story, a wide tool ecosystem, and a credible path from small offline deployment all the way to a stronger single-box setup. It also gives you a clean upgrade path. You can start small, learn the stack, then move upward without changing your whole mental model. If your main use cases are local coding help, private brainstorming, file-aware assistance, or a local first desktop server for 1 or 2 users, Gemma 4 is the least chaotic recommendation in this whole video. And that matters, because if your center of gravity is code, Qwen 3.6 is the model I would watch hardest. The official Qwen 3.635B A3B model card is unusually clear about its intent. It says the release prioritizes stability and real-world utility, and it specifically highlights agentic coding and repository-level reasoning. That is exactly the kind of promise developers care about, because the pain in coding workflows is almost never can the model write a cute, isolated function. The pain is whether it can stay coherent across files, follow existing patterns, preserve useful reasoning across turns, and not get lost halfway through a real repo task. The deployment story also matters. The official card points to compatibility with Hugging Face Transformers, vLLM, SGLang, and K-transformers. It even gives concrete serving examples with vLLM and with the lighter transformers serve path. That means Qwen is not only good on paper, it is already speaking the language of actual deployment. So here is the short version. If you want a serious open coding model for a stronger box, Qwen 3.6 is one of the best I actually want to build with this picks. It feels less like a demo flex and more like a tool that wants to live in your development loop. Now let's talk about the model everybody wants to brag about putting on the rack, DeepSeek V4. DeepSeek's official V4 release is extremely ambitious. V4 Pro is listed at 1.6 trillion total parameters with 49 billion active. V4 Flash is listed at 284 billion total with 13 billion active. DeepSeek also pushes 1 million token context as a default capability across official services and leans heavily into compute efficiency, sparse attention, and agent optimizations. It also says the models support OpenAI chat completions and Anthropic APIs, which is a big deal for tool compatibility. So yes, DeepSeek V4 is real. Yes, it is strategically important. And yes, it absolutely belongs in any serious local AI conversation. But here is the part people need to hear. DeepSeek V4 is not automatically the best first local model for most people. Why? Because there is a difference between open and easy to deploy well. DeepSeek V4 is the kind of model that rewards bigger memory budgets, smarter serving, and more careful infrastructure thinking. That makes it a great fit for ambitious builders, advanced home labs, shared internal servers, or hybrid setups where some requests stay local and some go through a compatible API path. It does not make it the easiest recommendation for someone trying to get a clean one-box local workflow running this weekend. So Mistral Small 4 is the useful wildcard in today's lineup. Mistral's official model card describes it as a hybrid model that unifies instruct, reasoning, and coding with 119 billion parameters and 6.5 billion active. More importantly, the feature list is broad. Chat completions, function calling, built-in tools, structured outputs, OCR, document Q&A, FIM completions, embeddings, moderations, audio transcription, and text-to-speech. That does not automatically make it the easiest, fully local choice for everyone. But it does make it a strong model to understand if you want a richer open stack that can stretch across developer workflows and document-heavy business use. So where does it fit? I would treat Mistral Small 4 as a strong hybrid or advanced stack option. If Gemma is the clean local first recommendation and Qwen is the coding-heavy recommendation, Mistral Small 4 is the one that makes you think about broader product surfaces. Now we need to talk stack, because model choice without serving choice is half a plan. If you are a beginner, the easiest on-ramp is still Ollama. Its docs are intentionally simple. It works across Mac OS, Windows, and Linux, and it gives you a fast way to pull down a model and start testing. If your goal is to get from zero to local chat quickly, Ollama is the low-friction path. If you want maximum flexibility on mixed hardware, quantized files, and smaller local rigs, llama.cpp is still one of the most important tools in the ecosystem. The official project is explicit about what makes it special: broad hardware support, aggressive quantization, CUDA and other backends, and even CPU plus GPU hybrid inference when the model is bigger than available vLLM. That one detail matters a lot. It means llama.cpp is often the smartest way to squeeze useful work out of hardware that is good, but not luxurious. If you are running a stronger Linux box and you care about serious serving, vLLM is the grown-up answer. The official quick start is very clear that it supports offline batched inference and online serving through an OpenAI-compatible server. That is what you want when the box is no longer just your personal toy and starts becoming a service. And then there is the front end. OpenWeb UI is a strong local-facing interface because it gives you a serious chat surface, model connections, and a multi-use. This is the part too many people skip. A strong local AI setup is not just a fast GPU and a cool model. It is a boundary decision. If you only remember one thing from this section, make it this. Your model server and your agent runtime are not the same thing, and they should not be treated with the same level of trust. OpenHands is useful here because the docs say the quiet part out loud. Its Docker runtime exists so arbitrary code can run in a sandboxed environment without risking the host system. The runtime architecture page explicitly lists the reasons: security, consistency, resource control, isolation, and reproducibility. That is exactly the right mindset for local agents too. And the warning on the process sandbox is even more important. The docs say that when the agent runs as a regular process, there is no sandbox isolation, and it can read, write, and execute on the host system with your account's access. Only use that in controlled environments. So the secure local pattern is simple: run your model server separately. Put your agent tools in a sandbox. Mount only the workspace you actually want the agent to touch. Treat admin settings and For most people, a good agentic workflow should look boring in the best possible way. Start with a base chat or coding model. Add retrieval only if you actually need documents. Add tool use only for the handful of actions that really save time. Put code execution or shell access behind a sandbox. And for anything destructive, add a human approval gate. That last part is not me being dramatic. LangChain's human-in-the-loop docs are explicit that certain actions should not run unsupervised. The docs walk through approve, edit, and reject decisions for tool calls. LangGraph's docs also focus heavily on durable execution, persistence, and human oversight for long-running workflows. That is the right pattern for local agents too. Not full autonomy, supervised autonomy. The clean version of the workflow looks like this. Model receives task. Retriever or context packer adds just the needed files or notes. Planner decides whether tools are required. Tools run in a sandboxed environment. Sensitive actions pause for human. Now for the part everybody actually wants. What should you do on a budget, and what becomes possible when you spend more? If your budget is tight, prioritize smaller, efficient models and smoother workflow over parameter vanity. That means Gemma 4 small variants, quantized local deployment, short to moderate context, and one-user workflows. Your win condition is responsiveness and privacy, not leaderboard dominance. If your budget is healthy, the sweet spot is a strong single-box setup built around enough memory to run a serious workstation class model without constant compromise. This is where Gemma 4 26B or 31B class thinking or Qwen 3.6 class coding setups start to make real sense. At this level, you can build a local first assistant that is genuinely useful every day. If your budget is bigger, now you stop thinking like a desktop user and start thinking like a small service operator. That means Linux, stronger serving software like vLLM, more careful agent sandboxing, cleaner UI separation, and more respect for concurrency, context length, and observability. This is also the zone where a DeepSeek-style open model style. Let me save you some pain. Pitfall 1. Buying for benchmark ego instead of daily fit. A model can be amazing on paper and still be the wrong answer for your actual loop. Pitfall 2. Oversizing context. Just because a model can stretch to huge context does not mean every task should. Long context burns resources. Use it when it earns its keep. Pitfall 3. Skipping sandboxing because it is just local. That is how agents get dangerous fast. Pitfall 4. Exposing your model and UI stack too casually. Local AI should live behind your own boundaries, not become an accidentally public service because you were rushing. Pitfall 5. Trying to make one model do every job. In practice, small fast models, coding-heavy models, and giant long context models often belong in different lanes. Pitfall 6. Ignoring operational boring stuff. Admin settings, user separation, mounts, logs, approval gates, update path. So if you want the cleanest answer to today's question, here it is. If you are new, start with Gemma 4 small models and a simple local stack. If you want the best serious workstation lane, look hard at Gemma 4 26B or 31B and Qwen 3.6 if coding is your main use case. If you want to study where open local AI is heading, respect DeepSeek V4, especially for long context and agent compatibility, but do not pretend it is the first stop for everybody. If you want a richer OpenStack model to evaluate, keep Mistral Small 4 in the conversation. Use Ollama for the easiest start, llama.cpp when squeezing hardware matters, vLLM when serving quality matters, Open Web UI when you want a real front end, and sandbox your agents before you trust them with anything important. That is the real local AI playbook right now. Right model, right stack, right budget, right boundaries. If you want more practical AI setup guides, subscribe. And in the comments, tell me your lane. Tiny offline assistant,